Welcome to another episode of AI 10X brought to you by 10 Leaves. Today, we are pointing our lens at a piece of source material that outlines what really feels like a fundamental shift in the technological landscape.
It really is a massive shift.
Yeah, the text we are analyzing is a dense, highly focused excerpt, and it's titled Quantum AI, the Frontier of Computational Intelligence. And the mission for this deep dive is to basically analyze the exact point where our current artificial intelligence models intersect with the architecture of quantum computing.
The title itself, it sets a very specific parameter for our analysis right out of the gate.
Yeah.
By using the phrase, the frontier of computational intelligence,
Right.
the source text immediately signals that we're, leaving the established paradigms of classical computing entirely behind.
Right.
We're examining an integration that promises to solve problems currently barricaded by massive computational complexity.
And that barrier, that massive computational complexity, is exactly why you, the listener, should care right now. We track the rapid advancement of AI models constantly, right? We note how they optimize our workflows or generate code and parse massive amounts of data.
And code out all the time.
Exactly. But the source text forces us to acknowledge this hard truth. No matter how sophisticated our current AI becomes, it is ultimately constrained by the physical and conceptual limits of classical computing hardware.
We have essentially built a highly advanced engine, but we're still running it on conventional roads.
Yeah.
The text posits that integrating AI with quantum mechanics removes those physical constraints completely. It opens up this theoretical space where the engine can operate in multiple dimensions simultaneously.
Okay, let's unpack this. What exactly is quantum AI, as defined by our source? Because it is crucial to strip away the sort of sci-fi connotations that usually accompany the word quantum and just look at the functional definition provided.
Right, no sci-fi here. The text provides a very clean operational definition. Quantum AI is the direct integration of quantum computing infrastructure with artificial intelligence models.
So it's a structural merger.
Exactly. It is the marriage of a probabilistic computational framework with advanced pattern recognition and machine learning algorithms.
Which brings us to the core problem this integration is trying to solve. The source material states the goal is to tackle problems that are far beyond classical limits.
What's fascinating here is how the text frames those classical limits. We know that classical computing, even at the absolute highest supercomputer level, relies on linear processing.
It forces a bottleneck.
Yes, exactly. To really visualize the massive computational complexity the text refers to, we can look at data processing as a vast library. We all know the bottleneck of classical computing. No matter how incredibly fast our current AI gets, it is still processing linearly.
Right, sequential.
Right, so if you have a library of 1 million books and you need to find one specific cross-reference, a classical AI might scan those books at blinding speed, but it is still fundamentally scanning them one by one.
And that sequential nature is the absolute wall. The AI is constrained by the necessity of time and sequence. But when the text introduces the quantum element, we are no longer talking about speed, we are talking about state.
State is the key word there.
A quantum system evaluates parallel states simultaneously. So in the context of that library analogy, the quantum AI model isn't just reading the books faster. It actually has the capacity to hold the contents of all 1 million books in its computational state at the exact same moment.
And that shift from sequential processing to simultaneous evaluation, it changes the definition of what is computationally possible.
It's a total paradigm shift.
It is. The AI is no longer bottlenecked by the hardware's need to execute step-by-step logic gates. It can evaluate a near infinite number of possibilities at once, which is why the text specifically targets massive computational complexity as the primary battleground for this technology.
So we're taking the reasoning and the pattern recognition capabilities of our very best AI models and giving them an environment where they don't have to wait in line to process variables.
Precisely.
And the source text is very clear that this is not just an abstract mathematical exercise. It outlines specific, high-stakes applications.
The text points us directly toward 3 distinct fields that are basically suffocating under the weight of their own data right now. Those are drug discovery, climate modeling, and cryptography.
Here's where it gets really interesting, because analyzing these 3 pillars gives us a concrete understanding of why shattering classical limits actually matters. Let's start with the first pillar, drug discovery.
Let's do it.
When we look at the current state of pharmaceutical development, the bottleneck isn't a lack of AI sophistication. It is the sheer mathematical wall of simulating biological environments.
Because biological systems are the ultimate expression of massive computational complexity. Creating a new targeted therapy requires predicting how a specific molecular structure will interact with a specific protein, and doing that under a cascading series of biological conditions.
Right, and if you think about the variables involved, the infinite ways a protein can fold, the millions of potential chemical compounds, a classical AI has to simulate those interactions in limited batches,
It is a process of highly educated but still highly constrained trial and error.
which takes forever.
Yes. The computational weight of simulating every possible molecular combination for a novel virus or a complex genetic disorder, it hits the classical limit almost instantly.
Which explains why developing new drugs is still a multi-year, often multi-decade process.
Exactly. But applying the quantum AI integration changes the methodology entirely. By leveraging simultaneous evaluation, the model can theoretically analyze the entire spectrum of molecular interactions at once.
It transitions the whole process from experimental screening to direct calculated synthesis. The AI wouldn't be searching for the right compound by eliminating the wrong ones sequentially.
No, it wouldn't need to.
It would use its quantum state to immediately identify the optimal molecular fit. The theoretical implication here is that the physical testing phase of drug discovery could be largely replaced by perfectly accurate quantum simulations.
Which would be revolutionary for human health. And moving from the microscopic scale of biology, the source text applies this exact same principle to the macroscopic scale of our planet. The second pillar is climate modeling.
And if drug discovery is about mapping finite but incredibly complex biological structures, climate modeling is about mapping a perpetually shifting, entirely interconnected system.
Ocean currents, atmospheric pressure, solar radiation, forest density. Every single variable influences the others in real time.
Which presents a very unique challenge for classical artificial intelligence. When a current AI model attempts to predict climate shifts, it basically has to compartmentalize the Earth. It slices the globe into a grid and calculates the changes in each distinct box sequentially.
But the Earth obviously doesn't operate in isolated boxes.
Exactly. So if I can ask a logistical question regarding the text's premise, if we are looking at climate modeling, how does a quantum AI even begin to ingest that kind of cascading simultaneous data without the model itself just collapsing under the noise?
The source implies that the quantum framework naturally aligns with cascading variables, because a quantum computer utilizes entanglement, where the state of one element directly relates to the state of another regardless of distance. It perfectly mirrors the physical reality of a climate system.
Oh, that makes sense.
Right, so a temperature shift in the Pacific doesn't just eventually affect the rainfall in the Amazon. In a quantum model, those variables are processed as an entangled simultaneous event.
It totally removes the lag time in the calculation. Classical computers choke on climate data because tracking the butterfly effect pushes sequential processing to its absolute breaking point.
They just can't keep up with the cascading changes.
But a quantum AI model could theoretically hold all of those shifting global variables in a unified computational state. We transition from making localized short-term weather predictions to modeling holistic, long-term Earth system outcomes with devastating precision.
And the ability to precisely model the interconnected outcomes of environmental policy or global temperature shifts leads directly into the third pillar mentioned in the text, which is cryptography.
This one is huge.
It is. This area represents both the most immediate threat and the most profound promise of quantum AI.
Because cryptography relies entirely on massive computational complexity as a defensive shield. The encryption securing our financial networks, national intelligence, and global communications is based on mathematical problems so dense that a classical computer would theoretically take millions of years to solve them.
We basically entrust our entire global digital infrastructure to the assumption that classical processing speeds have a hard limit.
A ceiling they can't break through.
Right. But the premise of quantum AI is the complete dismantling of that limit.
If a quantum AI can evaluate parallel states simultaneously, the mathematical problem that takes a classical supercomputer a million years could theoretically be solved in moments. The shield of sequential complexity is completely bypassed.
That is the disruptive potential. The integration of quantum mechanics with AI pattern recognition means that all current classical encryption algorithms are inherently vulnerable.
Which sounds terrifying.
It does, however. The text positions cryptography not just as a casualty, but as a pillar of innovation. Quantum AI offers the framework to establish new cryptographic systems based on the laws of quantum physics itself, rather than complex mathematics.
It forces a total reset of global digital security. We are looking at the development of encryption that is theoretically unbreakable because any attempt to observe or intercept the quantum data alters its state, immediately notifying the system of a breach.
Exactly. When you look at these three applications together, health, our planetary environment, and global security, the text is outlining the foundational architecture of human continuation. I want to pose a question to you, the listener. As you process the scope of these three pillars, what stands out to you?
That is a lot to consider.
When you consider the capacity to fundamentally map human biology, model the exact future of our climate, or completely rebuild the security of global information, which of these shifts feels the most structurally critical to our immediate future?
The incredible scale of these applications naturally prompts a critical look at the timeline. So what does this all mean for our current reality? Are we standing on the precipice of immediate deployment, or is the source text outlining a theoretical end state?
The source text provides a very necessary anchor here. It explicitly states that we are early.
That is a helpful reality check.
It is a grounded acknowledgement that the engineering challenges of building stable quantum hardware and maintaining delicate quantum states are immense.
It is vital to separate the theoretical capability of the models from the physical reality of the hardware. We are analyzing a frontier space. Frontiers are defined by instability, massive engineering hurdles, and experimental failures.
They are messy.
Right. The AI models exist, and the theoretical quantum physics exist, but stabilizing the integration is one of the most complex engineering tasks currently being attempted.
We are certainly in the foundational phase of this integration. However, the text follows that reality check with a defining assertion. It states that despite the early stage, these breakthroughs are poised to redefine computing itself.
That phrase carries immense weight. For the entirety of the digital age, our definition of computing has been iterative. We make transistors smaller, we make processors faster, we expand memory capacity.
But the foundational logic, the sequential processing of data has never changed.
Yeah.
If we connect this to the bigger picture, redefining computing means changing the mechanism by which we interrogate reality. We are moving from a system that calculates the universe one piece at a time to a system that processes complexity the way the universe actually operates.
Which is all at once.
All at once, in a massive, entangled state.
We are aligning the tool with the environment. Nature does not process biological interactions or climate shifts sequentially. By integrating artificial intelligence with a quantum framework, we are finally building an analytical model that mirrors the simultaneous complexity of the physical world.
That is the true impact of the frontier we are exploring. The breakthrough is not just an exponential increase in processing speed, it is a fundamental shift in our capacity to understand and manipulate complex systems.
To synthesize what we have extracted from the source material today, quantum AI represents the critical integration of quantum computing hardware with artificial intelligence models.
And its primary objective is to target massive computational complexity.
Yes, the specific problems where classical linear computing hits an impenetrable wall. By leveraging simultaneous evaluation, this technology aims to fundamentally alter drug discovery through complete molecular simulation, climate modeling through entangled variable processing, and cryptography by resetting the foundations of digital security.
Beautifully summarized.
And while the text grounds us in the reality that this technology is still in its early foundational stages, its ultimate trajectory is to shatter classical limits entirely and redefine the paradigm of computing.
As we conclude this deep dive, I want to direct your attention to the final claim made in the source text, that quantum AI could unlock the next era of intelligence.
That is a huge statement.
It is. Throughout our analysis, we've focused exclusively on the mechanics of machine intelligence, how the models will process data, how they will break through classical limits, and how they will solve massive complexities. But if we successfully build machines that can effortlessly untangle the world's most dense, interconnected problems, how will that redefine human intelligence?
That is the ultimate question.
Historically, our intellect has been defined by our capacity to solve complex puzzles. If we transition into an era where quantum AI serves as the ultimate problem solver, will the measure of human intelligence shift? Will our primary cognitive value no longer be our ability to find the answers, but rather our wisdom in knowing which questions to ask?
This was AI 10X, brought to you by 10 Leaves.